No, not your reference booklet. Today's notes. That one, sir. Yes. Yes, sir.
Are you recording?
I am recording. Like now, recording. Yes. Your questions will be recorded. Ready, guys? People are leaving early. Students, this is page 3. Ready? Write these 3 words. Write the word what. Write the word how. No. It's on page 3. Page 3. Just flip over the page, left-hand side where you were at. There you be. Okay, up here, write the word why. What? How? Why? Okay, you have those 3 words? Okay. In this math class, most of your math career, you have been focused on what is the answer. You have been focused on finding the value of x. In fact, down here, just write x equals, leave it blank. We'll solve that in a minute. Most of your math career has been, what's 2 plus 2? What's 10% of 120? What's the value of x? You've been focused on the what. Occasionally, you've been asked, how do you get the answer? And that's where you show your work, that whole show your work, show your steps. Very rarely have you been asked, why are your steps mathematically justifiable? That's what we're going to focus on today, is why. That's unique to geometry. You haven't done anything like this quite before. That's one reason why I'm recording it, so you can see it again if you need to. Okay, leave that page right there. Ready? Go back to this. I want you looking on the right-hand side where it says algebraic properties. I'm going to go through these super fast. Those of you who didn't fill it out, you need to find the video for this. It's on my website. It says reference book videos. You need to watch this. It's about 6 minutes in length. Okay, taking a look here. These are properties that you already know. Could you hit the lights for me, please? Thank you, ma'am. So in algebra, you can distribute. That's called distributive property. Here on the left, we collect like terms. When you add or subtract on one side, that's called addition or subtraction of real numbers. It's on one side of the equal side. Say one side. One side. Good. Here, these two, we're doing the clear thing. We add 2 to both sides. Or here, we multiply both sides. Whenever we do something to both sides, it's called a property. So this would be called the addition property. This, the multiplication property. When it's on both sides, it's property. Say both sides. Both sides. Property. Property. Okay. Then continue. You know that when you have a proportion, you can cross. Stop thinking for me and moving the page. When you have a proportion, you can cross multiply. Say, do you like your arm? Say cross multiply. Okay. You cross multiply, you never distribute in your head, you always leave that for a separate step. Last 2, if you have x squared equals 64, the way you backtrack a square is you square root both sides. The no-no here, if you have x squared equals 64, you do not divide by 2. This 2 does not cancel that 2, because that's an exponent. Okay. Last one, if I have 3x equals blank, and over here I tell you x equals 8, I can take out the x, put in 8, and I get 24. What's that called? Say it.
Substitution property.
Okay, so keep this right under your nose. You're going to need it. Keep it right there. Ready? Go back to this page. Let me show you what I mean here. Let's actually solve this step by step. Step 1, we do this. What this is what was the algebraic property from this page that gave you the permission to take that step. I call it the Mother May I. When you play Mother May I, it's like you have to ask permission to do something. So to go from one step to the other, what allows you to take that step? Ready? Write it down. What was the property or process that allowed you to take that step? Write it down. I'm going to pester someone in about 10 seconds. Kelsey, what happened there? What did we do? Yes, that way I'll never forget again. Okay, distributive. That was the mother may I or the permission to go from step to step. Let's do another one. We're going to collect like terms. Okay, look really closely. Did we add both sides or only on one side? Both or one, guys? Which one is it? Only one. So we say addition of real numbers. If it was both sides, you say property. From here, let's clear the 14. Stay right with me, guys. You'll get a break in a few minutes. We subtracted one side or both sides. Out loud? Both sides. So this one we call it subtraction property. Last but not least, fill that out. I'll pester someone in about 10 seconds. Eric, what do you think? What do we do? Both sides. So is that division of real number or division property? Lovely. Great. So we write that is division property. So what we have here is there's your what's the answer. That's what you've been focused on mostly. The left, now you show how you got the answer. The right, that tells us why is your answer mathematically justifiable. Okay, look at the clock. In the next 7 minutes, so you have until the 50. I'd like you to finish these two problems yourselves. I'll give you the answers in 7 minutes. If you finish early, bounce over to page 7. Start working. Lights, please, somebody. You can talk, you can interact, you can help each other, but you've got 7 minutes to get this figured out. This is time, guys, so focus. Okay, so there's more than one way. Like these two steps in the middle, these could probably be switched. Some of you minus the 4x, or you did whatever. So don't change it, but as long as both of these should have property because you're working on both sides. That's what's important. Last one's division property because you divided both sides. Question, yes, sir?
Wouldn't the second one be distributive property?
Technically distributive property, yes. I just writing too fast. Thank you, Garrett. Keeping me what's called truthful. All right. So that is how you do a what, how, and why in algebra. Now we're going to do that for geometry. I'm going to show you the whys. This will take us about 5 minutes, and then I'll give you a quick little break. Ready? Come here. Lights, please. Lights. Lights, lights. Ready? Write this down. This will just take us 5 minutes. Oh. Is it frozen? It's not frozen. Good. We did this last class. Last class, we learned little segments add up to bigger segments. Little segments add up to bigger segments. So that one's easy because you just learned that. This one is also really easy. Just write ST. You're welcome to rotate your desk around. You're welcome to rotate your desk if you're having a hard time seeing. So this one says ST is the same as TS. That's called symmetric. Segments can be symmetric. It's kind of common sense. This isn't really that hard. This one by far is the most, no, not that one. This one right here is by far the most important. Let me highlight it. Most important, most common. Start writing. Okay, so what we have going on here is we have CA and AT are equal. Notice the red hatch marks. There's one set. CA and AT are equal. I'm telling you that. Then I also tell you that segment AS, that AT and ST are equal. TS are equal. You see it? Look really carefully. Circle what segment's in both. Circle what segment is in both of these. Which one? What segment's in both? Circle it. Circle it. Circle it. Circle it. What's in both? Circle it. Now say it out loud. What is it? AT. So this is like saying if a first is equal to the second and second is equal to third, what can you say about the first and third? They're the same. So we're going to transfer congruency. We say therefore, those little three dots mean therefore, CA is therefore congruent to TS. We call that transitive. Transitive. Transitive, think transfer. You transfer congruency. Transitive, transfer. Say those two words. Transitive, transfer. Say it again out loud. Transitive, transfer. Okay. These last two, we'll take our break. This one looks a little weird. Just a little. Ready? Shade this and shade that. Darken the center one. Do you see that these two triangles share this segment? This segment is like an apartment wall. It's shared between two apartments. That segment is exactly shared by two segments. So we mark it as congruent to itself, and you write HI is congruent to HI. Looks a little weird. You won't really use this today. You'll use this in about a month. This is called reflexive. Looks a little strange, a little redundant, but it'll come into play in about a month. Reflexive, like a mirror. Sorry about that. Okay, let's do H, J, and K here. It's our last one. We'll take a break. Let's say HJ, the distance H to J is 5. Write it down. Put a little bracket. And let's say we also know that HJ is equal to JK, so hatch markers. Therefore, I want you to write in what's the most logical conclusion there. Write it down. I'll picture someone in about 10 seconds. If you know HI is 5 and HJ is 5 and HJ is the same as JK, what's the most logical conclusion? Write it down. Don't say it out loud. Write it down. Write it down. What's the most logical conclusion? Alec, what do you think, sir? What's the most logical conclusion? Right, which means JK is going to measure what?
5.
Bingo. That's called substitution. You take one thing out, put another thing in. But I have a very specific way that we do what's called geometric explanations, or the word proofs. And I want you to circle these 4 letters. G-I-F-T. Circle them. Given, implied, freebies, talk through. Say those 4 words out loud. Given, implied, freebies, talk through. Just write this down. I'll explain it in a minute. Prove. Sorry, my handwriting degrades. Wait till your parents get here at 7 o'clock at night and they'll be lucky to read anything. Alrighty guys, so given, you mark the given and the prove on the diagram. Your habit will be to completely ignore the diagrams because you're not used to interacting with diagrams. That's why I give you that little reminder in the right. No naked diagrams. You'll figure that out in a minute. Okay. 2, you mark what's implied, again, on the diagram. 3, freebies. You locate and mark freebies. Freebies are things that are true even if they're not in the given. Last, you talk through the logic. Underline or highlight talk through. Talk through. Notice I had you talk through the crown activity before you wrote stuff down. That's because you talk faster than you write. So you want to organize your thoughts by talking first because you can do it faster. Then you capture your talk and you write it out. I'll show you what that is in just a moment. Ready? Turn the page. If you have colors, if you have 3 highlighters, that's the best. Or 3 different colors of any kind, get them out. We're going to do 2 proofs together. We'll do one, take a short break, and do another one, and then you guys will be on your own. What's there? No, originally it was scheduled, but then we figured out it was parents' night, which for us teachers doing that on parents' night is like that. We have, our day's barely half over by the time school ends. All right, guys, ready? Given. We have that given. Watch with me. I need about 3 minutes of silence right now. So there's like 2 people. You're like jabbering slightly constantly. I can barely hear it, so focus. You'll get lost. Focus. I'll give you a chance to talk in about 3 minutes. Ready? Faster than that. Point B, so circle B, is a midpoint. So I just write midpoint, abbreviate, of A to C. So I'm going to bracket A to C and hatch marks. That's because of that word midpoint. Raj, please don't distract Jonathan right now. Yeah. Okay, Jonathan, can you rotate your desk just slightly so you don't have to look over your shoulder so far? Thank you. Okay, ready? Mark it. Now watch. As soon as you account for something, cross it out so you don't get lost. Point C is the midpoint of B to D. So bracket, second midpoint, double hatch. Okay, so the red has a midpoint, the blue has a midpoint. And you see those hatch marks. Here's what we're trying to prove. We're trying to prove, and that word prove, don't be freaked out with that word prove. That just means explain. You guys know how to explain stuff all the time. You're really good at explaining, especially if you're trying to get out of trouble. You know how to explain stuff. Okay? All right, we're trying to explain, given that, how would you know that A to B is the same as C to D? Okay, facilitators, this is your job. Facilitators, you'll start. Facilitators, your job is to get every single person to talk. You've only got about 10 seconds. The question is this. If you know the red information and the blue, how do you know the yellows are equal? Facilitators, start with yourself and then make sure every person in your group explains this verbally. Given this scenario, how do you know the yellows are equal? Go, talk. Each person must talk for 10 seconds. Step here. Let's do this one together. Step one. Let's start with what's given. We knew that B is the midpoint of A to C. So it reads like a sentence. I know that B is the midpoint of AC because, out loud, why do we know that? Where do we get that information? No, it's given. So because it is given. Okay, I need to go back to the silence and focus now. You'll get a chance to talk again in about 3 minutes. All right. Now, because of that midpoint, there were 2 equal segments. I'd like you to write it out. Do not say it. I want to see if people can find it themselves. Because of B, using 2 letters here and 2 letters here, I'd like you to write down what's equal. Write it out. Don't say it out loud. I'll pester someone in about 10 seconds. Michaela, what do you think? Okay, AB is equal to what? Okay, no, we know because of B, we know AB is equal to what? Say it out loud, ma'am. Okay, BC. Did you say BC? Because I thought you said CD. Okay, then I just wasn't listening. I apologize. We know that because of the midpoint. So you just write definition of a midpoint. That's your because. That's your why. This is your why column. Okay. Now, let's get our other given. We know C is the midpoint of CD. Because, why? It's in the given. Now, because of the blue, I'd like you to write down what 2 segments are now equal. What 2 segments, the distances are equal. Write it down. Which 2 pieces are equal because of C being the midpoint. Because of C being the midpoint. Stefano, what do you think?
I think that if C is the midpoint of BD,
yes, sir.
then BC and CD is...
Exactly. BC and CD are the same because, again, definition of a midpoint. Look very carefully at these 2. Whoops, daisy. Look very carefully at here and here. Ready? I'd like you to circle what's exactly the same. What's in the same about those lines? Circle it. What segment repeats itself? Circle it, please. What segment? Okay, Bianca, what segment repeats, ma'am? BC, I'd like you to box it. Okay? We can transfer because AB is equal to BC and BC is equal to this. Therefore, AB must therefore be equal to CD. Why? Transitive, because we transfer, transitive. Congratulations, you just finished your first geometric proof. Geometric proof. Not too painful. Not too painful. Alrighty, guys. Okay, we're going to follow gifts. Given, implied, freebies, talk it through. Just put that in the margin. Given, implied, freebies, talk it through. So given, we start by marking the given on the diagram. So we have CD and EF are equal. So here's EF and here's CD. And they are equal, so, and check. I took care of that. We can always do that. All right, what else are we given? We are given the fact that DF and FG are equal. So DF and FG are equal. That's our second set, so that's a double hatch. Check, I took care of that. What we're trying to prove is if the yellow and the blue are equal, how do we know C all the way to F, this big pink or whatever color you're using, and E all the way to G, why is that equal? No, don't say it. Hang on just a second. So let me repeat one more time. In a moment you're going to talk, and I do want you to talk this out. Take about 10 seconds each. The premise is this. If you know the yellows are equal, and you know the blues are equal, I want you to talk through, it only takes about 10 seconds, how on earth do you know for sure the pinks are equal? Ready? Talk. Go. Ready? We talked it through. Step 1, CF and FE are equal. I'm going to keep up with my colors. Okay, for the next 3 minutes, absolutely no talking. Focus. If you need to, rotate your desk. This is not easy. I need you focused. We know the yellow is true because it's given. Now ready? Here's DF. Here's FG. Look, DF, FG. See the colors are the same? We know those are equal. Why? Out loud? Given. Good. It's also given. We're a third of the way there. Now, at some point, we have to talk about either CF or EG. Somehow, we have to get that like out of the fridge and on the counter before we cook. So we have to say something about CF that's true. So I'd like you to bracket CF, please. Just bracket. Now, I'd like you to just bunny hop these 2 steps. Do those little segments add up to the big one, yes or no? Yes. Good, that's true. So watch what I can say. I can say that the pink is made up of the yellow and the blue. In my case, whatever color it is for you. And the reason is that's called segment addition. Segment addition. Now, circle with me, please. Ready? Circle CD. Come up, find CD here. Go to the right. CD equals what piece? Out, EF. Ready? Box this. Draw a little arrow. Circle DF. I have 4 of you not tracking with me. Pick up your pencil, track with me. Circle DF. Come up here, circle DF. Box the FG. Come down here, box the FG. Little arrow. Ready? Have a short discussion, verbal discussion, 10 seconds. What happened? What do we do from here to here? From this to this. What do we do? Okay, work with me. We took out one thing, we put in something else. What do we call that? Out loud, what do we call it? Fabulous. We substituted. Okay, now, so we have CF. Now we need to talk about EG. So come up here, bracket EG. Now bunny hop the 2 pieces that make up EG. So EG, the pink, is made up of EF, which is the yellow, and FG, which was blue. We know that because of segment addition. Little pieces add up to big pieces. And we said that because somehow we needed to get EG out of the fridge and on the counter. Ready? I'd like you to box this for me, please. Ready? Box this. Box this. Look very carefully. Bullet, bullet, bullet. I want you to have a short discussion. Talk about what happened between these two bullets that gave us this. Talk about it. What happened here to get you this? Look, talk, go. What happened? Talk about it. See those two top bullets? Really carefully. What happened between here, these two together? How did we get that? That's all there.
All right, you're going to take
So what happened? Last guy? All right, guys, ready? Did you guys notice that these are exactly the same thing? Yes or no? Yes. That these are the same. What can you say about these? Where we swap out the expression, we pop this in. Behold, substitution. Yes.